Welcome to LG Lesson 3, putting it all together, the 3 stages of LGQ analysis. Just a note before we go any further, a couple notes really. This one does presume that you have seen Lesson 1 and 2. I'm not going to completely skip all the content that was covered there. I will refer back to some of it just to make sure that everybody's on the same page. But in particular when it comes to the June 2007 exam, and the third game, the one about the cruise line. I am not going to set that one up again. I'm just going to kind of dive right into it when we come to it in the latter half of this lesson. So just be on the lookout for that. You may, if you've done that one already, you may want to pull your work out, especially if you did it together with me in lesson 2. All right, moving forward. A quick recap on what we've done thus far. Lesson 1 covered how to move through a game's setup phase without doing deductions, or at least without putting any actual effort into deductions. The next step, Lesson 2, covered how you end up answering questions by filling in diagrams, giving yourself the most room to succeed. And these do go hand in hand. So the fear that a lot of people have is that you've been told, most likely by most test prep sources, including any books that you've used for self-study, that deductions are pretty important. And I don't want to downplay their power when you do find them, but it's their unreliability for most people, and the fact that they turn into a time sink for most people is what makes it problematic. And I really haven't seen a really good way to do them that's widely applicable over the past 14 plus, almost 15 years I've done this. So that's why I developed Lesson 1, which is just really, it almost has no real content in the sense that all I'm demonstrating is that you can skip that step. That there's a way to get to the questions and begin working on the questions without doing the deductive stage. Lesson 2 then kind of is where the rubber first hits the road, where, okay, so you've made it to the questions without doing any deductions or doing an absolutely minimal amount of deductive work. How do you actually answer some of them? And so I purposefully chose some questions that weren't particularly complex and that were very amenable to a plug-and-chug, grinded-out brute force approach. So yeah, that's where we are so far. Now the problem with Lesson 2 is the thing that I just alluded to on the previous slide. I really only did questions that required us to evaluate answer choices. There's a big gap by that approach, which is the following. What happens when the question stem itself provides some additional information we need to account for? In those situations, it's not enough to do what we did in Lesson 2. You can't just go straight to the answer choices and begin plugging them in to see if they fulfill one of the could be true, must be false, or could be false conditions on these questions. So this is a very important thing because there is a very solid mix. I never really did a count, but I would be surprised if the majority of questions don't provide some additional information. So this is a pretty big gap left by Lesson 2. So what am I talking about when I say a question stem itself providing additional information? What I mean by that is if a question stem provides additional information, something like if M is in slot 4, which one of the following must be true, that alone generates a number of hypothetical possibilities before we even get to answer choices. So the question itself could possibly demand that you do a little bit of diagramming and a little bit of predictive work. So again, this has nothing to do with answer choices yet. The question itself directs you to a situation that potentially leads to a lot of drawing and diagramming. And that's the problem for many test takers, precisely that. How far do you take that hypothetical situation posed by the question stem? How many possibilities should you work out? This is where a lot of people get lost. So in other words, at what point should you stop diagramming based on the question stem and start diagramming based on the answers like we did in Lesson 2? So again, this is a pain point for the vast majority of high scorers that I've seen who've come to me, and also pretty much anybody else who's come to me, even if you're not already scoring in the 160s. This is an issue because you're good enough and you've done enough practice to see that in the proposed hypothetical question, if M is in slot 4, which of the following must be true, that alone generates a number of possibilities, and because you have some skill and familiarity, the temptation is to sit there and try to figure out as much as possible. And that's good instinct, and you need to do that. But what this lesson really is going to be focused on is helping you control and make use of that instinct. It's not to say don't do any work, because that's pretty counterproductive, but at the same time, it is very easy to get stuck into a quagmire of doing too many possibilities, finding out that there's like 5 or 6, and then maybe even further variations within that. So you could even be dealing with double digit scenarios in larger games. That's a problem. That is a big problem. Such problems are precisely why this lesson exists. So in this lesson, we will cover the 3 stages of analysis for LG questions. and more importantly, the crucial issue of when to move from stage 2 to stage 3 analysis. So obviously you don't know yet what the stages are because we haven't done that, but just as reference, stage 2 is the part where you're making diagrams based on the question stem's information. And stage 3 is when you move on to making diagrams based on the answer choices in order to see which ones work and which ones don't. So again, there will be 3 stages of analysis covered, and the most important thing to walk away from with this lesson is getting some idea of why and how it is important to move between stage 2, diagrams based on the question stem, and get into stage 3, making diagrams based on answer choices to figure out which answer is the one that you're looking for. So just another little aside here before we get into it. A lot of what's to come in the next few slides might be non-intuitive in the abstract without the helpful context of actual questions, but examples will follow the exposition pretty shortly, so hang in there as we get over the abstract concept part. So the very first issue we have to deal with before we even discuss what the stages themselves actually are is these 3 stages of analysis. Which questions do they apply to? To start off with, they apply only to questions where we actually need to attempt filling in diagrams repeatedly. So the biggest exception to the 3 levels of analysis is the rule checker question that usually comes first in every game. If you recall from the one that we did together in lesson 2, and it's the same for pretty much all the rule checker questions out there, all you are doing in those questions is taking the first rule, checking all the answer choices against it, seeing which ones violate that rule, eliminating them, and then moving to the second rule and doing the same thing. And you just continue the process with each and every rule until 4 out of the 5 answer choices have been eliminated, and then you pick that one and you move on. That doesn't really require diagramming, so that really isn't going to be part of our 3-stage analysis discussion here. The other question type that I can pretty unequivocally say doesn't really get into this too deep is the rule changer question. And those are those nightmarish questions that occasionally come up at the end of a game. And it's the one where they say, say rule number 2 doesn't exist. Which one of the following would have the equivalent effect on the outcome of the game if we replace rule 2 with that answer choice? Those do have some diagramming usually just to test answer choices, but at the same time, you don't really have to do this whole 3-stage analysis. And given that so many people have trouble with that one, I will have a separate short lesson on that, maybe in the Insights playlist or maybe somewhere else as a sort of extra LR lesson 4 maybe. I'm still a little bit up in the air about how I'm going to address that. But that will not really have a place here. So now that we've discussed which questions don't use the 3 levels of analysis, it begs the question, well, which questions do use the 3 levels of analysis? And that means pretty much everything else. The vast majority of questions that we end up doing this 3-stage analysis for end in could be true, must be false, must be true, or could be false. So that, if that sounds familiar to you, rightly so. Those are the vast majority of questions that we see. So those questions, i.e. most of the section, are where this 3-stage analysis is going to be fairly important if you are doing a low deduction approach. And just as a final note, some of the other question types, the partial and complete and accurate list situations, might benefit from this approach, but still the bread and butter of the 3-stage analysis is going to be the could be true, must be false, must be true, could be false that we just listed out here. So let's start with defining what the 3 stages actually are. Stage 1 is to incorporate any information provided by the stem into your diagram, as well as anything else that must be true based on that information. I would say that this is mostly self-explanatory, so if a question stem says put something in slot 7, you do that in stage 1, and then immediately after that you check to see if there's any mandatory outcome of that information, and that's pretty much all of stage 1. The one caveat to this is that there are open-ended questions, right? The ones that only say which one of the following could be false, and they don't provide any context or helpful information to add on top of what you already have. So again, open-ended questions are the ones that just simply say something like which one of the following could be false, which one of the following could be true, with no extra information. For those questions, there is no stage 1, because there is no extra information to incorporate. So after you've done stage 1, that is, after you've taken the information that the stem gives you, you've put it in the diagram, and then you've figured out any mandatory consequences of putting said information into your diagram, you're done with stage 1. That means you are now ready to move on to stage 2. Stage 2 is to take your information from stage 1 and begin spinning out possible outcomes based on what could be true. So what that means is if stage 1, the question stem told you, put T in slot 7, You put T immediately in slot 7. You figured out a mandatory outcome of that, but that leaves 6 more blanks left open on the board. You're looking at other entities. Maybe you're interested in M for whatever reason, and you see that M can go in slot 1, 4, 5, 6, whatever it is. And you're beginning to see a bunch of possibilities. Maybe you're not going to see anything mandatory, you're not going to see something that must be true, but you're beginning to see that there's a lot of possibilities based on your stage 1 information. And that's the bread and butter of stage 2, when you're spinning out possibilities based only on what could be true. Now, as for the ideal results from stage 2, they don't have to be completely filled in diagrams. That's actually relatively rare. That's, as I say later on, if we're lucky, stage 2 gives you a complete diagram that has you, gets you all the way to the finish line in terms of an answer choice. For the most part, we will be dealing with partially completed diagrams from stage 2. That means that if you're dealing with a 7-slot diagram, maybe you've only got 4 of them filled in by the time you're done with stage 2. That's usually more than enough. That's usually good enough. Having the remaining 3 totally being up in the air, that's fine. That's where we plug in answer choices and do stage 3 stuff. So I just want to emphasize again that stage 2 is about testing various possibilities. You don't want to overdo this. You just want to, and we'll get into the line between overdoing it and doing it just right. But for the most part, you just want to do maybe up to 3 possibilities, no more than that. Just do those possibilities. Don't feel the need to chase completed diagrams each and every time. Do what you can, figure out what you can, and then move on to stage 3. Now, the final caveat before we discuss stage 3 is that, again, for open-ended questions, there is also no stage 2. So open-ended questions are kind of a different beast entirely. They're almost purely stage 3, which we'll get into in a moment. So again, just because I've added a lot of aside, to concisely sum up what stage 2 is, stage 2 builds on stage 1 by allowing you to spin out possible outcomes based on what could be true. You're going to have a number of diagrams here if you so choose to make diagrams for it, and most of them are not going to be complete, and that's fine. So as I said on the stage 2 slide we just got past, sometimes stage 2 is enough to get us all the way to the finish line. It's enough to get us to an answer choice, but many times it is not. That's where stage 3 comes into play. So stage 3 is when you begin plugging in answer choices to your stage 2 work. If stage 2 isn't enough to get you an answer, you just start with answer choice A, plug it right into your stage 2 work if you have any, and then after you plug it in, you kind of process it according to the table that I have at the bottom of the page here. So skipping down to the bottom of the page, you'll see that I have 4 bullet points with 2 sort of responses underneath them. So I'll just kind of go through the table. If a question ends in could be true and you are on stage 3, what you do is you plug in the answer choice as it's written. If it works, then you end up selecting that answer. If it doesn't, of course, you don't pick it, you move on to the next one, and you go on until you find one that does work. A very similar process for must-be-false questions. Again, if you've done stage 1 and stage 2 for a must-be-false question and you still need to work on stage 3 at this point, then what you do in stage 3 is you take the answer choice, plug it in as it is, as it's written, and if it works, then you eliminate that answer. Moving over to the right-hand column, if you're on stage 3 and you're working on a must-be-true question, this is a little bit odd. Because it's difficult to prove that something must affirmatively be true in all times and all places, that's a pretty tall order. The most we can generally do is only prove that something could be true. So how do we actually go about proving that something must be true? We kind of get at it from the other side, from the reverse. So in a must-be-true situation, during stage 3, what you are doing is you are plugging in an alternative to the answer choice. So you're not plugging in the answer as written, you are plugging in an alternative. If you can get that alternative to work, you eliminate that answer. So again, you do not plug in the answer choice as it is. You just plug in a reasonable alternative, and of course we'll get to how to come up with alternatives. But suffice it to say for now, you plug in an alternative, and if that alternative works, you eliminate that answer. And finally, we have our last category that could be false. This works quite similarly to must be true. When you're on stage 3 and you're testing a could be false question, plug in an alternative to the answer choice that you're testing. And if that alternative works, you select that answer. So we'll see the table at work when we get to questions later on, but this table is kind of handy. I'm surprised that more people and more test prep, maybe things have changed, I don't know, but at least when I stopped teaching for corporate test prep, this really didn't exist in any sort of codified format, and truth be told, some courses, at least the ones that I'm familiar with, did kind of cover all of these scenarios, but they very rarely, put them in a table so that you could just see how they all stack up. So I find this to be one of the handiest things that I give out to my students here. All right, so kind of going back to where we left off on this slide. Um, as an example, if your stage 2 work happen to lead to 2 or 3 general possibilities, most of the time the answer choices that you're plugging into your stage 2 work are only going to fit into 1 or 2 of them. That's just how things tend to play out. So if you're afraid of, okay, I've got 3 diagrams, man, I've got to now test 5 answer choices against all 3 of these diagrams. It's like 15 total. It really doesn't work that way. Most of the time, the answer choice is really only individually going to fit into 1, maybe 2 of your general possibilities that you've worked out from stage 2. And aside from that, for open-ended questions that lack stage 1 and 2, what you do is you just start with the answer choice and you plug it into your otherwise blank diagram. So even though a little bit earlier I was like, oh, take your answer choice, plug it into your stage 2 work. If you have no stage 2 work, that's fine. You'll still have a blank diagram, right? You just take the answer choice, throw it into the blank diagram, and then follow what the table says. I refer to this table only half jokingly as the table of power, as kind of a weird, nerdy reference to Lord of the Rings and the One Ring, right? The one ring that rules them all. This is the one table that guides all of your analysis. So that's why I always say it's half jokingly, because I really do think that if you're kind of lost, kind of struggling, and your problem is not so much that you don't know how to do games, so much as you know how to do games in general, but every single game you just run across that question or that answer choice where you just don't even know where to start. The table of power will tell you exactly what to do in any situation, even if you fail to do any stage 2 work, and let's say you were kind of supposed to. Generally speaking, this table of power will still get you there. It will still get you there as long as you're consistent with the rules and you understand all the information that the game is throwing at you. So before we move on to doing some actual demonstration work, another note about the table of power and how it works out. The single most common concerns that plagues my students is, okay, I managed to fill out one diagram based on stage 1, stage 2, and stage 3 at this point, but don't I need to worry about the other possibilities? There is such a thing as a dumb question, and this is one of them. You don't need to. You don't need to. If you follow the table of power, no, you do not need to concern yourself with the other possibilities. The reason for this is that the table of power is designed in a way to ensure that the diagram that you just completed happens to be the one that proves the one thing the question wants you to prove, no more, no less. So if you follow the table of power pretty faithfully, you won't need to concern yourself with other possibilities unless you have failed to fill in a diagram. That's the only time you kind of look around to see, okay, did I do something wrong? Is there another possibility that I need to try? But anytime you manage to complete a diagram using the table of power, which is going to be the case the vast majority of the time, like I would say, 99% literally, once you've managed to complete a diagram and you have followed the dictates of the table of power, you're going to end up right where you need to be. You don't need to worry about anything else because your efforts have been properly directed at proving the proper thing. But again, I understand that a lot of this may sound abstract, a lot of it might sound weird. Just hang on a little bit, we will get to the demonstrations in just a moment here. I do want to note here that there is a little bit more that I can discuss about the table of power, its origins, and how it came to be, and why each and every step works the way it does. But I don't really feel like embarking on a deeper discussion of the table right now. But I'll end with saying that its power comes from always having you do the right thing for the right situation, as we just said on the last slide. And I'd also like to note that I'd be happy to discuss all those details that I'm not discussing right now, because this is going to be a long enough video as it is. But it's one of those things that if you still have questions, despite everything that's been said about the table here, at that point it's going to be easier for me to do it over voice with specific questions that you have with specific games, rather than give you a generalized one-size-fits-all explanation as a video like this kind of demands. So again, there's more to it. If you want more detail, there will be contact details at the end of this presentation, as well as you can find it at any time in the sort of About Me section of my channel here. So now we are actually going to start heading into questions. But before, I know I keep teasing you guys, so we'll get to questions. We really will. Just hang on a second. Just to give you context, though, for what we're doing. The purpose of what I'll be demonstrating overall in this next section is to eventually demonstrate how and when you should move between stage 2 and stage 3. Because if you recall, it's been a few minutes at this point. If you recall, that was the point of this lesson, is that most people struggle with moving past stage 2 into stage 3 when stage 2 isn't enough. So to demonstrate that, we'll be going over 3 situations. The first situation that I'll demonstrate a question on is when only stage 2 is necessary. That means you do stage 1, and then you do stage 2, and finishing stage 2 happens to be enough to get you to an answer choice. So I'll demonstrate what that looks like. And actually, we've seen some of that in other places, but that's a discussion for another time. After we do that, I will show you a question where only stage 3 is necessary. You can skip this part if you have seen lesson 2, because lesson 2 basically dealt only with pure stage 3 questions. But for those of you who are unfamiliar and just want another review, after we do the only stage 2 questions, we'll be doing an only stage 3 question. So you'll have an idea of what only stage 2 looks like and what only stage 3 looks like. And finally, after we have established sort of the baseline boundaries of that, we will work on a question where both stage 2 and 3 are necessary. So, there's a question where stage 2 work is called for and you do it, but it leaves open a lot of possibilities. And there are going to be too many possibilities to kind of feasibly draw out before we get into stage 3. So I will demonstrate the red flags of knowing when a question is a pure stage 2 question and when it should be something that you kind of cut short your work on stage 2 and move into stage 3, and where exactly that line is for me. And of course, after that, I will discuss how you personally can find your own line for that. So again, we're going to start with a pure stage 2 question. Next, I'll show you what a pure stage 3 question looks like. And only after that, I will show you what a transitionary sort of middle ground question is, where you need to do stage 2 and you also need to know how to move into stage 3, because stage 2 can be a trap for you. So finally, we're past the abstract stuff and we'll be starting our first question here. So as I've been saying, there are a number of questions out there where stage 2 is enough. You do stage 1, you do stage 2, and you're done because stage 2 got you to an answer choice. Our first such example is from the 07 exam, section 1, question 1. So it's the very first question of the very first game, which reads, if the last digit of an acceptable product code is 1, it must be true that blank. So I just want to make a note here that the STEM itself doesn't tell me that stage 2 is enough. I'm not going to know that until I actually do it. The other thing I want to note is that we haven't actually set this game up together. And I do want to note that there is a low effort deduction that you can get from just reading the rules and doing the setup, according to the procedure that I have laid out in lesson 1 of this series. But just to kind of demonstrate the power of understanding rules and the power of the low deduction approach, I'm actually not even going to discuss that here. That deduction is something that you can find just by applying the rules, and it's not like the rules are particularly complicated in this case. So if you just can flip open to this game, even if you haven't prepared it beforehand or haven't done it before, you should be able to follow along just by referring to the rules that I mentioned here without knowing anything about it ahead of time. The one thing I will note, it is a simple sequencing game, a simple ordering game, so the diagram for it is just going to be 5 blanks, and that's it. There's nothing else to put in there, it's just 5 blanks in a row. So, starting right up with stage 1, we take the information from the question stem and drop it right into our diagram. So, the information from our stem was that the last digit of the code that we're looking for is number 1. So we just throw the entity 1 at the end of our diagram here, and we're done with stage 1. Stage 2. This is where we begin to check rule interactions and fill in things that are possible. And we'll see here that actually stage 2 kind of bleeds into stage 1 here, because it turns out a lot of things have to be true, even though it wasn't obvious to us if we hadn't set this up ahead of time. But in the spirit of kind of doing it, we're just going to pretend like we're in stage 2 here, because that's the mindset that I'm in, because I didn't do any deductions ahead of time. I don't really know anything that is a mandatory outcome. So I think stage 1 is done when I throw 1 in there. And now I'm just looking at the rules and trying to fill in the rest of the picture and see what the possibilities are. If you look at the list of rules for this particular game, rule 4 is the obvious place to start, because it tells us that the number in our 3rd slot has to be less than the number in our 5th slot. The number in our 5th slot, according to the STEM, is the digit 1. 1 is a pretty small number, right, as far as whole numbers are concerned. Of the entities that we have available, there is only one number that is lesser in value than 1, which is 0. So since the question stem tells us that 1 goes in the 5th slot, the only way to make the 3rd slot lesser in value than the 5th slot is to put 0. So we'd end up with this configuration: blank, blank, 0, blank, 1. And that again is according to rule 4 and the information that we have in our question stem. After we've done that, after we've taken care of the obvious rule 4 here, rule 3 seems like the next obvious place to go. What rule 3 tells us is that the 2nd slot is exactly twice the value of the 1st slot. With the remaining entities that we have available, the only way we can accomplish what rule 3 wants us to do is to drop the entity 2 in our 1st slot, and then drop the entity 4 in our 2nd slot, like so. So we have 2, 4, 0, blank, and a 1. Now at this point, the only slot left unfilled is the fourth one, and the only entity that we can put in there is 3. So conveniently, we end up with 2, 4, 0, 3, 1. Our stage 2 work, therefore, has yielded a complete diagram, and it matches with answer choice A, which asserts that 2 must go into the first slot. So there's no need to test anything else. So again, if you had done this game before, or if you're still holding on to a deduction-heavy approach, you probably could have reached this a little bit faster, because you would have known immediately that if 1 is last, that means 2 and 4 goes first, and 0 is third, and 3 is the only one that goes. Like, that would have come maybe a few seconds faster, but yeah, you can get there just as fast by being methodical with the rules as I have here. You didn't need to know ahead of time that 1 being in the last slot automatically forces 2 and 4 to go up front. You didn't need to know that. That happened as we were just putting it into the rules, and it really takes. You really lose almost nothing by not doing that deduction. So yeah, either way, we ended up doing stage 2, and stage 2 was a lot more restrictive than we thought. We were trying possibilities, and it turned out every time we turned, the next thing we tried to do, we actually only had one option. There weren't multiple possibilities. There was only one possibility. I didn't know that before doing this question. I didn't know until I started my stage 2 work. But either way, I did stage 1, and then I did stage 2, and stage 2 turned out to give us enough information to pick answer choice A, because that's the one picture that we have to end up with matches the condition that A describes, which is that 2 has to go first. And I would like to emphasize again, you're done here. You don't actually need to do anything else. So this is an example of a question where stage 2 work got you all the way over the finish line. Okay, so we just did a question where stage 2 was enough. We didn't need to do any stage 3 work. Let's go to the other thing. What happens when a question doesn't allow you to do any stage 1 and stage 2 work, and you're relying purely on stage 3? What does such a question look like? As I mentioned, the open-ended questions fall under that category. So completely open-ended questions give us nothing to use for stages 1 and 2, so we head right into stage 3. And conveniently, the very next question on that same game is exactly such a question. So in the June 2007 exam, section 1, question 2, which one of the following must be true about any acceptable product code? This is open-ended. This is a must-be-true question, but it's open-ended. It doesn't give us any extra hint. It doesn't talk to us like question 1 did, and it didn't tell us that one of our entities has to go in one of the slots they specify. There's no such information. That makes this an open-ended question. So this being a must-be-true question, when we begin working on testing our answer choices with a purely stage 3 analysis, the table of power dictates that we have to plug in an alternative to the answer choice that we are testing. And based on that alternative, we attempt to fill out a completed diagram. If we manage to get a completed diagram out of that alternative, we eliminate the answer choice, and then we repeat the process for the next answer choice until we find one where the alternative that we try is the one that works. So what does that actually look like? So lacking any stage 1 or stage 2 context to work with, going straight to stage 3 means we start right up with answer choice A. There's no reason not to. Just start at the top of the list and work our way down. So let's test answer choice A here, which alleges that 1 must appear before, in other words, must appear to the left of 2, somewhere in our diagram. I want to call your attention to the yellow highlighted text in case the yellow highlight is somehow not enough. We can actually eliminate A immediately based on our work from question 1. We discovered in that question that 2, 4, 0, 3, 1 is a valid diagram. And in that case, 1 clearly does not have to appear to the left of 2. In fact, 1 is all the way to the right and 2 is all the way to the left. So it quite extremely does not have to be true that 1 appears to the left of 2. However, if we didn't have the benefit of this previous work for whatever reason, either you skipped it or you didn't think to refer back to it, there could be any number of reasons, we can kind of demonstrate the power of a stage 3 analysis by just plugging that in without the benefit of any prior knowledge. So to do that here, we'd start by plugging in an alternative to A, because this is a must-be-true question, and the table of power tells us that in a must-be-true question, instead of plugging in an answer choice as it's written, we want to see if we can get an alternative to the answer choice to work. So in this game, the only way to avoid putting 1 before 2, as the answer choice suggests, is to have 1 after 2. As a side note, in some different games, not this one, some ordering games actually allow for ties or shared positions, so having 1 and 2 appear in the same slot could also be a potential alternative that you need to test. But again, we don't need to do that here. We are dealing with a very standard ordering situation, no ties, no sharing of slots, so we don't have to worry about that. Moving on, the next thing you want to note at this point is that there are a number of different ways we can actually have this alternative 1 appearing after 2. Don't get worried about all the possibilities. Just start with the first one and stick with it until it proves impossible to work with. So, to actually have the rubber meet the road here, we are going to plug in our alternative to answer choice A in a manner that leaves us the most room to succeed. And of course, the whole most room to succeed concept is gone over in much greater detail in LG Lesson 2 of this series, but we'll see it on the next slide as well. Again, presuming that we've done 0 deductive work so far, and we don't otherwise know ahead of time that the only 2 ways to start this diagram in this entire game for all the questions is to have 2 and 4 in the leading slots or 1 and 2 in the leading slots, we are going to pretend like we don't actually know that and start with a completely blank diagram. So with that in mind, if we make our alternative of 1 appearing after 2, if we want to make that work, we would maximize our chances of succeeding if we put 1 as far to the right as possible and 2 as far to the left as possible. That leaves us with a diagram of 2, blank, 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 1. Starting with the rules from the very top, that's how we're going to finish in the rest of this diagram. Rule 1 and 2 don't really help us here, so we will instead go right into Rule 3. Rule 3 tells us the second slot is exactly twice the value of the first slot. That means we end up with 2, 4, blank, blank, 1, and that's just how math works, right? Of the numbers that we have remaining, which are 0, 3, and 4, the only way to fulfill Rule 3 with the numbers that we have is to put 4 in the second slot. Note also that this should start to look a little bit familiar to you at this point. This is probably going to end up the same, if not identical, to what we had from question 1. Now, moving on to Rule 4, since we're done with Rule 3, that requires us to have the third slot be lower in value than the fifth slot. So again, the number that we put in the third spot is just smaller than the number that we have in the fifth spot. The only remaining numbers that we have at this point are 0 and 3, so only 0 can really go into the third spot. Again, because the only number that we can use that's smaller than 1 is 0. So we end up with 2, 4, 0, blank, 1. Now 3 is the only number that we have left, and it has to go into the fourth slot because that's the only place that we could possibly put it at this point. Now all that remains is to check the completed diagram against all the rules. So even though we literally checked this exact same diagram for question 1 and we know it works, may as well check it again for completion's sake. So looking at rule number 1, which tells us that the codes use the digits 0, 1, 2, 3, and 4, and no others. Yeah, those are the only 5 numbers that we used. We didn't use any extra weird numbers. We didn't leave any out, so rule 1 checks out. Rule 2, each digit occurs exactly once in any code. That also works out. We used 0, 1, 2, 3, and 4. Of course, not in that order, but we used all 5 of them. None of them repeat, so we used them each exactly once. Rule 2 checks out. Rule 3 tells us the second digit has a value exactly twice that of the first. Yeah, we literally just did that less than a minute ago. 4 is exactly twice the value of 2, so that's just math. That's how it works. We're all good there. And rule number 4, the value of the third digit is less than the value of the fifth digit. And again, 0 is smaller than 1. 0 is in spot 3. 1 is in spot 5. So spot 3 is smaller than spot 5. We're all good there. So what does this mean? This means that our chosen alternative, which was 1 appearing after 2, that alternative worked. That in turn means that the original, which is the idea that 1 has to appear before 2, that original idea does not have to be true. Again, we just proved that an alternative to that original idea works. That's why we can safely eliminate A and move on to B, as this is a must-be-true question, and we have just proven that answer choice A does not have to be true. Having thus eliminated answer choice A, we move right along to B. B, in turn, alleges that 1 must appear before 3. Much like answer choice A, we can actually eliminate B with no further work, thanks to what we saw in both question 1 and now answer choice A for question 2. So we've seen that same combination, and both times we didn't have to have 1 appear before 3. But again, presuming that we don't have the benefit of the prior work for whatever reason, we are going to do this the stage 3 way, which is to plug in an alternative. So the only alternative that we can have of 1 appearing before 3, or the only way to stray from that, is to have 1 after 3. So again, assuming that we know nothing about the 1 and 2 and 2 and 4 lead-off breakdown, let's just try a straight up most room to succeed scenario. Like last time, that would leave us with something like this. 3, blank, 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 1. And I know some of you are already saying, oh, that's, are already looking ahead to rule 3 and saying that doesn't work. Yeah, I know, I get it. But again, we're presuming that we don't have the deductions, that we're in a rush, or we didn't do previous work, we're kind of pressured, whatever it is. This is just to show the power of the most room to succeed methodology. So with this admittedly already erroneous diagram, we are going to head into the rules. Again, I see that rules 1 and 2 are of not much use in filling in the diagram, so we're gonna go right to rule 3, and this is what should set off alarm bells if you didn't already see them. There's no way in this scenario with 3, blank, 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 1, there's no way for us to have the second slot exactly twice the value of the first slot if we put 3 first, because there's no 6 that we can use, right? We're only allowed to use 0, 1, 2, 3, 4. There is no 6. That would be the only way to make rule 3 happy. So there's clearly something wrong with our diagram. We cannot put 3 in the first slot. That's our problem. So even if we move 3 back to the second slot to get blank 3, blank, blank 1, that's still a problem with rule 3 because we don't have anything that's exactly half of 3 now to drop in the first slot. So putting 3 in slot 2 still runs us afoul of the requirements of rule 3. So let's say we push 3 one more time into the third slot with blank, blank, 3, blank, 1, and finally this seems to make us safe from rule 3. So having finished our work with rule 3 with regard to placing the entity 3, we move on to rule 4, but alas, rule 4 tells us that our third slot must be lower valued than our fifth slot. So we end up pushing 3 yet one more time to get blank, 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 3, 1. Finally, with regard to the entity 3 and our alternative having 1 after 3, finally we are safe from both rules 3 and 4. And, like I said, we are still faithful to our chosen alternative of somehow putting 1 after 3. So this is where our work kind of begins now. Now that we've secured our alternative on the board, we're going to go back through the rules again to fill out the rest of the diagram. So starting right back up with rule 3, because again, rule 1 and 2 don't really help us a whole lot. They're just kind of baseline conditions. Starting with rule 3, we see that the only way to fulfill rule 3 is to have the familiar combination 2 and 4 up front. Because again, rule 3 wants the second slot to be exactly twice that of the first slot. And of course, the numbers that we have left are 0, 2, and 4. So 2, 4, blank, 3, 1 is what we end up with so far, based on rule 3. And again, this should be looking pretty familiar. We finish this diagram off by dropping 0 into the third slot to end up with our old familiar friend 2, 4, 0, 3, 1. So just like in answer choice A, we have proven that it is possible to place 1 after 3. So it doesn't have to be true that 1 must appear before 3, as B alleges. That allows us to eliminate B and move on to C. So yeah, it's kind of boring, I know, where we're always ending up with the same combination. Obviously, that's probably not going to hold up for the rest of the game. But the whole point of this was to show that you can just kind of start with a blank slate and still get to a fully fleshed out diagram, even if you didn't figure out deductions ahead of time. And I'll address that a little bit further on the next slide. So I can hear you guys saying it already because I've heard it a million times every time I demonstrate something like this. A quick word about what we just did for B. But James, why are you so dumb? Why are you so slow? If you had just used the very obvious 1, 2, 2, 4 breakdown deduction from the start, that would make things so much faster. Yeah, you're right. That is correct. However, the point that I was trying to show is that even if you don't bother to bring any such deduction, even really obvious ones, even if you don't bother to bring any deductions with you before you start judging and assessing answer choices, the same information, that exact same information, ends up hitting you in the face repeatedly. Not even across questions, within the same question, so many times. If you are being faithful to the rules, you will never miss a deduction. Because where do deductions come from? They come from the rules. They come from the rules. So the rules are the source of everything, really. So even you didn't even have to spend the minimal effort required, the minimal brain power required to come up with the 1, 2, 2, 4 breakdown, because that's always it's always going to make itself very obvious, because you're always going to run into rule 3, and if you're doing rule 3 properly, you'll notice that, hey, of the numbers I have left, I can't actually fulfill rule 3, so something's got to change about my picture. So that's the whole point. So to put it another way, even just into the very, very beginning of work on question 2, you should have encountered the dumb 1, 2, 2, 4 breakdown several times, all thanks to Rule 3. Rule 3 is where that deduction comes from. You don't have to know that explicitly ahead of time. Sure, it'll save some time, and of course, I want to get to the real core of the lesson here, which is to mix stage 2 and stage 3. I will definitely address this, and you could definitely put it to work, and that will definitely be faster. But the idea is, if you are fastidious about adhering to every single one of the rules, you don't need to worry about missing these mysterious deductions. I just do want to make another note. While this particular deduction, the 1, 2, 2, 4 breakdown, is admittedly one of the simplest possible deductions out there, many deductions are nowhere near as obvious. You've probably seen this, right? You do a game, you struggle heavily, and then you go check 7 Sage or whatever other answer key that kind of explains things for you, and they're like, oh, this deduction, blah, blah, blah. I was like, man, I didn't see that. That happens all the time. So even if a deduction is hard to figure out, though, it'll kind of play out the same way as this really super easy 1, 2, 2, 4 thing. The deduction will reveal itself by question 2 or 3 much through the same mechanism. Because again, deductions come from the rules. As long as you are sticking with the rules, and the rules are not hidden, they're written right out there for you to interpret. As long as you are properly interpreting the rules, every single little deductive secret is going to come out anyway. So why spend like 3, maybe even 4 minutes in extreme cases, scratching for deductions that you're probably not going to find, or you're going to characterize incorrectly? Why waste time ahead of time when you can, in that same time that you're wasting looking for deductions and not finding them, you can start answering questions and figure out the deduction while getting points at the same time. It's just like a triple whammy. It's not there's no question. I will die on this hill. This is, for most people, a very superior approach. Now, I'm not saying that this is how you should do every question. That's not what I'm saying. I'm saying that whenever you do feel lost and you are in a situation where, man, I really feel like there's some deduction about this game that I'm close to seeing it, but I just can't get it down. Don't worry about it. Just do stage 3 is always there to pick up the slack for you. The table of power is always going to be there to help you get through all that crap. That's the big advantage of the no deductions methodology. It's not that you should never use deductions if you can see them, but you will never be at a loss for what to do, and you will always be able to keep moving. And not only can you keep moving, you will get questions right. Okay, so now having eliminated both A and B, we are now moving on to C. C, in turn, alleges that 2 must appear before 3. In fact, this is another one that we can kind of do without doing any work. As the first highlighted portion states right here, Rule 3 ensures that C, in fact, must be true at all times, because the only two ways to satisfy Rule 3, and at this point I'm not going to pretend like we don't know this deduction. If you've been doing the eliminations, you will have run into this enough that, you've got some problems if you haven't seen this yet. We know so far from our work that the only 2 ways to satisfy Rule 3 is that 1 and 2 lead off, or 2 and 4 lead off. And in both situations, 3 has to appear somewhere later than 2. So in a 1-2 situation, 3 can only appear in slot 3, 4, or 5. Same thing with the 2, 4. The only place we could ever put 3 is somewhere in spot 3, 4, and 5. And unfortunately, in both cases, 2 is up front somewhere. So yeah, by Rule 3 alone, 3 has to appear somewhere later than 2. But again, even if by some gross, happenstance or unfortunate collection of circumstances, let's say you just happen to skip to this question because the rest of the game wasn't working for you, you're under time pressure, whatever it is. Let's say we fail to deduce from R3 that C is what we're looking for. If we end up doing something like blank, blank, 3, blank, 2, because again, if we find out that putting 3 in spot 1 has problems, 3 in spot 2 has problems, we might end up with something like this, right? Where you read Rule 3 and you didn't get the 1, 2, 2, 4 breakdown, but you at least recognize that you have to leave those 2 slots free of the number 3, because there's no way to respect the Rule 3 relationship, the x2x relationship that Rule 3 lays out by having 3 up there. Even if we didn't see the 1, 2, 2, 4 breakdown, we at least know that we need to keep 3 out of spot 1 and spot 2. So we end up with 3 blank 2, because that would be the alternative to 2 appearing before 3, which is having 2 appear after 3. We maybe get as far as adding blank, blank, 3, 4, 2 at the end to satisfy R4. But we'd eventually have to come back and consider the 2x aspect of R3. So even if we mess up and throw the number 4 in the fourth slot, when we go back and try to fill in slots 1 and 2, we're going to end up with 0 and 1, right? That doesn't satisfy the x-2x relationship. So at which point we realize that we can't pull that off the remaining 0 and 1. So we know that we have to rejigger our picture, and we could end up with a similar process, and we probably end up with a very similar approach, and we'd end up with 2, 4, 0, 3, 1 again. And that again proves when you have 2, 4, 0, 3, 1 that it's not true that 2, or it must be true that 2 actually has to appear before 3. There's no way for us to get 2 out of the first 2, and there's no way for us to get 3 into the first 2. So 2 is always going to end up at the left of 3. If you are careful about rule 3, you'll get there. You'll get there. Even if you start off wrong, you'll find out quickly that there's no way to go against what C is saying. I decided to go with this hypothetical erroneous start because we've all done something like the above. In a hurry to finish, usually, we've forgotten, ignored, or simply missed the impact of a rule or an interaction, and we made a completely filled-in diagram. And we did it wrong. The only antidote to this is to get into the habit of always checking any complete diagram against the entire list of rules. You'll always catch mistakes and misses that way. You'll never end up with something wrong like 0, 1, 3, 4, 2. If you're checking the rules, you're gonna find out that that's not gonna work. So you'll never make that kind of mistake. So again, the rules are everything. So long story short, the answer is C. Just to review again, rule 3 alone is enough to prove that C has to be true. There's simply no way for us to get 3 in front of 2 in our diagram, no matter how you cut it. So now that we've reviewed a situation where stage 2 is enough to get you to an answer choice, and where stage 3 is enough to get you to an answer choice, I do want to make a note here. A purely stage 3 analysis is one of those things that sounds more cumbersome than it actually is, but admittedly it's still cumbersome. Things do go better when you are using both easy low-hanging deductions that you might have found, as well as other rule-based eliminations that don't require extensive diagramming. The whole point, again, of testing answer choice B and C the way we did in question 2 was to show that even if you are being inefficient, as long as you are being consistent, it's not going to take you that long to find out where things are going wrong and where some of the hard stops are when it comes to the rules. Rule 3 is a hard stop in a lot of ways. You can start filling in a diagram erroneously, but very quickly, if you are not respecting Rule 3, you will find out that your diagram doesn't work. And again, as easy as it is if you practice this, I do admit, because it's the truth, that it is not always the most efficient way. So the TLDR here, the message, the long story short, is that when you already know how to manage filling in diagrams, the process of brute force testing answer choices in stage 3 is much more streamlined than I made it look. But that being said, it's not using stage 3 alone is not always the right answer. So as I was kind of repeating myself on the previous slide, a purely stage 3 analysis, especially when it comes to open-ended, must be true questions. It is a bit work intensive. Successful test takers, therefore, always use everything available at their disposal. That means pushing stage 2 as far as is helpful to you when it's possible, and developing a sense of how the rules interact with each other within just the first few questions. And again, that comes from just being fastidious about applying every single rule and taking the time not to find deductions ahead of time, but to actually make sure that you understand what the rule is telling you. So a brute force, purely stage 3 analysis, though, can get you every single correct answer every single time, but it's difficult to get it all done in time. So just to give you my experience, I've personally tested this purely stage 3 approach, and I have managed to ace, I say here, ace an LG section well within 35 minutes. I can do it pretty much for any section, really. But the exception is that I'm exceptional. I'm really good at this stuff, atypically so. So I wouldn't really advise a pure stage 3 approach for anyone. And again, I didn't do it because I thought it was better. I just wanted to see how far I could take it, and it turns out I could take it from beginning to end. But it's not the way I would personally choose to do it myself anyway. So because of that, I wouldn't suggest a pure stage 3 approach to anyone for every single question. It's only when you really have no other choice that you start looking at it that way. So as I've been saying, the real deal, the people who score well on this exam, use both stages 2 and 3 together whenever possible. So questions that can be answered with purely stage 2 or purely stage 3 are fairly straightforward. A little cumbersome, maybe, yes, but they're straightforward. You're looking at just the information from the question stem in stage 2, and then in stage 3 you're looking at pretty much just the information from the answer choice that you're testing. It's pretty simplistic that way. The real problem is when a question invites some measure of stage 2 analysis, but that isn't enough to get you to an answer choice. So you're starting a question, it gives you a little hint in the stem, and so you start working on it, but man, there's a lot of possibilities. And you start to worry that if you don't try them out, you're not going to see it coming, you're going to get it wrong, blah, 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 blah. So that's really where a lot of people run into problems, because it's hard to tell sometimes when to stop spitting out possibilities and when to start plugging in answer choices. So as I've highlighted here, the key skill is to develop a sense of how far to push stage 2 analysis before kind of giving up is the wrong way to put it, but before making the judgment call to wisely head into stage 3. So this is really the beginning of the core aspect of this lesson, which is again, when do you stop stage 2 to head into stage 3? So to demonstrate the pitfalls of pushing too hard in stage 3 pushing too hard in stage 2 versus leaning just hard enough into stage 2, we're going to be going back to the game that we are working on in lesson 2. And that is again the June 2007 exam, section 1, questions 11 through 17. In particular, we'll be looking at question 16, as I think it's a good place to demonstrate when stage 2 can get out of hand and how to stop it from getting out of hand. So this particular question, number 16, gives us an extra piece of information, namely that M goes into slot 3. That means that this question is eligible for some stage 2 work, but there is a lot of potential stage 2 work you could do if you are not careful. So I'm not going to bore you by demonstrating the exact and complete process. Again, if you really want these details, I'd be happy to go into greater detail individually. Contact me via the email address that I have posted in the About Me section of the channel, as well as at the end of every presentation that I put up here. But these are just some of the possibilities based on the little tidbit of information that question 16 gave us in its stem. There's at least, what is it, like 5 here, and then 6 if we count the J/T variance of possibility number 4. You get the idea. There's a lot of ways to fill this in, and I don't even know if this is all of them. I think there may arguably be a couple more lines I could write. The point is, you could sit there spinning out a lot of different possibilities, and that's a bit of a waste of time. So a much smarter approach would be to stop stage 2 after you find the first 2 or 3 possibilities, but instead just make sure that you understand some of the important interactions and then push right into stage 3. So what would such an approach look like? Well, glad you asked. That's exactly what we're going to talk about here. This is what that approach would look like for question 16. So again, the stem tells us that M is in slot 3. So in stage 1 of our question analysis, that's exactly what we do. We drop the entity M right into slot 3, so we end up with the following picture. Blank, blank, M, followed by 3 more blanks, and then a T to bring up the rear. Because T is there because of one of the rules always puts it there. So that is pretty much it. I don't think there's anything else that mandatorily has to be true based on putting M in slot 3, so we can just kind of stop there. Now stage 2 is where, again, the problems could happen. How do we judge a question like this, and how can we tell that stage 2 is potentially a trap for us? We'll start with, as always, as we do in stage 2, with the rule analysis. So starting with rule 0. The opening paragraph tells us that the 4 destinations have to show up at least once. So of the letters, I'm trying to think of where I can fit G, J, M, and T. We've already taken M and T. We've already put them on the board, so we really have to account only for G and J at this point. And J is kind of interesting because I've seen it in a couple of different rule situations. If you don't recall, go back to lesson 2. We deal with it fairly extensively. So rule 0, getting us to think about putting in the other 2 letters so that we represent G, J, M, and T, which is what rule 0 tells us. That naturally leads me to thinking about J, and thinking about J leads me to rule 4, which tells us anytime we drop a J in our picture, we've got to have a G directly in front of it. So again, we know that the GJ block is something that we have to account for. The next natural thing to think about when you're thinking about the entity J is rule number 1. Rule number 1 tells us that J isn't allowed to be in slot 4. So any possibility I try needs to leave room for a GJ block that doesn't put J in that forbidden slot. So what does that lead us to? Three different possibilities at the very least. Ideally, you're not going to be drawing any of this out. This is just something you can do visually. You just have this 2-slot block of G and J that you can just kind of mentally move around here. When we combine Rule 0 with Rule 4 and Rule 1 now, that gets us three possibilities. GJ up front, in front of the M that the question then places. The next possibility is to leave M and T where they are, and then put the GJ block immediately after M. And finally, the last place we could fit the GJ block is to have it all the way to the end touching T there. Those are immediate possibilities that you can fairly easily imagine without even drawing them out, so try to get into the habit of doing that without forcing yourself to draw it. It's literally just seeing that GJ is a 2-slot block and you've got plenty of places to fit in that 2-slot block. 3 is plenty in my mind. And 3 is plenty. That is our first red flag, that leaning further into stage 2 might be counterproductive. As a general rule when I'm teaching students, I advise against mapping out more than 3 possibilities. And we've already hit that limit with this very simple GJ block that we're trying to move around. So moving forward, I am actively resisting the urge to draw possibilities. I mean, I'm already naturally doing that because I'm always wary of situations like this where too much stage 2 work is a trap. So that's me personally. But even if you didn't know, I'm telling you now. At this point, by the very fact that something so simple as just moving this GJ block around yielded 3 possibilities, which I think is kind of the hard cap of what you should try before giving up on stage 2 and moving to stage 3. I am now on full alert. Like, okay, there's a lot of possibilities that I can tell so far, and I haven't even tried other things. I haven't even accounted for other things yet. So my head, the alarm klaxons are already going off. I'm like, okay, this is a dangerous stage 2 situation. So I'm actively resisting the urge to draw out more possibilities, doing so only if I have trouble visualizing it. But thankfully, this is a pretty straightforward ordering situation, so there's not a whole lot of visualization that I have to do. Instead of drawing things out and trying possibilities, the only thing I'm going to be doing is just trying to gain or solidify my general understanding of the important blocks and how they interact. So even if our experience on the previous slide with just rules 0, 1, and 4 weren't enough to convince you that this is a dangerous trap situation, let's say you moved on to rule 3 just to be like, okay, maybe rules 0, 4, and 1 led to some uncertainty. But what if we look at rule 3, which we haven't considered yet? Does that give us any sort of extra certainty that the previous set of rules didn't? Let's try it out. Rule 3 tells us there has to be exactly one more M placed, and it has to be spaced out in a manner that you can fit a G, at least one of the G's that appears, between the 2 M's that we have on the board. Again, personally, I wouldn't feel the need to draw anything out because I think I could visualize this easily enough. But in case you can't, here it is on the page. The possibilities when it comes to spacing out that second M and the M that we already have on the board are as follows. M, G, M, 3 blanks, and a T. 2 blanks with an MGM group in the middle there, and then another blank capped off with T at the end. And then finally we have 2 blanks, M, 2 blanks, the second M, and our T. So if we combine the above with our knowledge of Rule 0 and Rule 1, we can see that the last 2 possibilities that I've listed on the lines above are actually just variants of some of our Rule 0, Rule 4, Rule 1 work. And again, you don't even need to pay attention to this. All of this is really just telling you the next point. This is our second red flag. If the first slide wasn't enough, if the previous slide wasn't enough to convince you that there's just too much variability, this should be the final nail in the coffin, or the second big red flag. Just get out, get out, get out, get out. The lurking danger indicated by our Rule 0, Rule 4, Rule 1 work has really been confirmed by adding Rule 3 into the mix, which adds at least 2, likely up to 4 possibilities. Again, don't even worry about counting all the possibilities. It's more than 3. It looks like a lot more than 3. Even if you don't know exactly how much it is, if it just feels like too much work to you, which hopefully it should at this point, like just don't do it. Don't worry about it. Stop doing stage 2. All you need to know is like, okay, I've tried a couple of things. I didn't draw all of them out, but I'm beginning to see how things interact. The GJ block is kind of important because we've got to fit it in somewhere because we have to use a J at least once. And anytime we use a J, we've got to stick a G in front of it, so that's got to show up. That limits our freedom. The second M, there's still a whole lot of different places that we can place the second M according to Rule 3. That doesn't really help us. So there's just too much variability. So ideally, again, you wouldn't have drawn anything out, not on this slide or even on the previous slide, but you would have just seen that M has more variance and that it gets worse if you add the GJ block into the mix. So I should take that back. Depending on which rule you started with, whether you started with Rule 3 or whether you started with Rule 0 in the GJ block, maybe you would have drawn some things just because you didn't know ahead of time that this was going to be a trap like I did. But the trap should make itself really apparent as soon as you start trying possibilities. There's just way too many. There's way too many out there. So just because Stage 2 does ask that we go over all of the rules just to see if there's any further deductive work that we can do, I'm just going to do it for completion's sake. But by the time I'm looking at Rule 5, which is the only one we haven't really considered, other than Rule 2, which is just the simple one that always puts T in slot 7. Aside from that, Rule 5 is the only one we need to consider. But by the time I get down to Rule 5, I am fully in abandoned Stage 2 mode. And I am just 1,000,000% reading the rule only to make sure I account for it when I'm moving to Stage 3. But thankfully for us, Rule 5 is really simple, and the only thing that it tells us is that we should never see the same letter touching a copy of itself. That's it. So yeah, easy enough, right? So a recap of where we are so far on our work in question 16. Even at the earliest parts of Stage 2 for this question, there were a lot of warning signs that the hypothetical situation posed by the information given in the question 16 stem, it leads to too many possibilities to work with efficiently. Trying to spin them all out is going to take forever. Even better, question 16 happens to be the 5th question in the set. It's the second to last one you do. If you've been going in order, and you can quite easily if you have a no deduction, Stage 3 heavy approach, if you've been going in order, you should have a relatively firm grasp by this point of the basic mechanics of the game. So you understand which entities create limits for each other, you will have encountered the GJ block issue, you would have seen that the second M isn't quite as free as it looks, but it also doesn't lock things down immediately. These are things you should have developed a sense for at this point. Not that you have to, but you probably have at this point. Eventually, you should get to a point with your LG skill in general with enough practice that you should see the initial situation posed by the question stem, which again is blank blank M in slot 3, blank 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 T. You should be able to see that and be like, okay, there's probably a lot of variability there. If you're thinking about the rule that tells you that there's a second M, you're thinking about the GJ block, and you're seeing that, okay, I've got quite a bit of flexibility here. I can kind of mix match, push things around. Even without drawing everything out, you recognize that there's quite a bit of variability. So the TLDR here is that very early in Stage 2, there are enough red flags to let you know not to lean too hard into Stage 2. And instead, your goal in Stage 2 should just be to just check all the rules just to make sure that you have a firm grasp of what each one does and how some of them interact. And really just to use that Stage 2 work, it's hard to call it work because you're not actually writing anything down, but to use your Stage 2 analysis to the extent that you do it to get ready to push into Stage 3. So now that we have made our peace with abandoning Stage 2 because of the high variability, and we have just decided to only take into account how the rules work in a general sense, now we have everything that we need to move into Stage 3. So beginning Stage 3, we could just plug and chug A and move right down the list. That works too. But anytime, this is an adjustment that I would suggest that you make. Anytime a question stem gives us a bit of information, much like question 16 does, I like to see if any of the answer choices are immediately eliminable. And spell check is telling me that eliminable is not a word. Google tells me otherwise, but I use eliminable here in the pretty obvious sense, eliminatable. So answers that you can eliminate. So the first thing that I notice is that the question actually wants us to find a viable pair of letters to insert into slots 4 and 5. So that's what the actual answer choices are supposed to represent in question 16. So when you're thinking about slot 4, I'm immediately thinking of rule number 1 because that's the one that mentions slot 4 explicitly. So rule 1 tells us that J can never be in slot 4. So any answer choice that lists J first, which is to say it lists J in the 4th slot, that can be eliminated, which lets us eliminate B because there in that answer choice, J is supposedly in slot 4. We know that that's a direct violation of rule 1, so B can never be what we're looking for. While we are on the subject of J, we would also do well to remember Rule 4, which again explicitly mentions J. Anytime we see a J, Rule 4 tells us that we've got to put a G immediately in front of it. So any answer choice that lists J second but doesn't have G in front of it is out, which lets us eliminate D immediately because it lists J second but doesn't put G in front of it. So that clearly doesn't work. And as far as I can tell, those B and D are the only easy rule-based eliminations that we can have at this point. So now, having exhausted stage 2 and have also made some easy eliminations before actually doing stage 3, now we have just 3 answer choices to work with, so we may as well just start with the first one that still remains, which is answer choice A. So since this is a could be true type question, all we're going to do according to the table of power is plug in the first answer choice that we're testing, which is A, and see if we can get it to work with our picture from stage 1 and stage 2, and get it to work as it's written. So answer choice A alleges that the letters G and T are in slots 4 and 5. So being a could be true question, we throw them right in slot 4 and 5 and see if we can get it to work, and that's what we get. Blank, blank, M, G, T, blank, and T. So after that, after we have this picture here, I am immediately seeing that the only place to drop the GJ block that we've come across in stage 2 is up front. So if I add that into what the answer choices already put in there, we have G, J, M, G, T, blank, T. So we only have one open slot remaining, which is slot 6, and as for slot 6, the only thing that I know immediately that it can't be is T because of Rule 5. Rule 5 forbids having us have two T's next to each other. And there's a T flanking either side of slot 6, so obviously T can't go in there. We also know that it can't be J, because as we've run across multiple times at this point, Rule 4 tells us that J triggers into a GJ pair, or in other words, anytime we drop a J in the picture, we've got to put a G directly in front of it. So if we put a J in slot 6 here, we have no room to throw that G, so we're not going to do that. So that leaves really only G and M as possibilities, but Rule 3 tells us that we have to have a second M, so we may as well throw M in there because that's something that we need as well. So taking Rule 3 into account, this is what we get. G, J, M, G, T, M, T. So we can quickly check that against all the rules, even though we've kind of been doing that along the way anyway, from start to finish, and it does conform to all of them, including our Rule 0. I'm not going to, this video is long enough already, so I'm not going to go through them individually, but if you want to, pause the video, check it against all your rules, this checks out. So therefore, what that means is that A is a valid possibility, a valid way to fill in slots 4 and 5, and we select it. Because the answer choice, which is GT in slots 4 and 5, we were able to fill in a picture successfully based on that allegation. And so it could be true, and could be true is what our question is asking, so we select it. The other answer choice, let's say A didn't happen to be the answer choice we were looking for. Let's say it didn't give us GT, it gave us something else, and that was further down the line. We just move on to C, and if that doesn't work, we move on to E. But, at this point, we're only testing 3 answer choices, not all 5, because we made 2 easy rule eliminations. So it really, wherever it appeared, it wouldn't have taken us that much longer to get to it. So again, just to make sure that everyone's still on the same page, I'll recap our work for question 16 in the context of all 3 stages. So question STEM 16 tells us that if M is in slot 3, which of the following can be a possible configuration of slot 4 and 5? So stage 1, the first thing we do is to drop M into slot 3, and then we are looking for anything else that is a mandatory outcome of that information. And for this game, there isn't anything definite that results from putting M into slot 3. That was the whole point of this, right? There's a lot of variability. So nothing much to do there. We're going to continue trying to see the possibilities in stage 2. There's nothing mandatory, so we're done with stage 1. But let's see how the possibilities play out with stage 2. We see that the initial diagram of blank blank M, blank 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 T, it's really rife with possibility. And you can that alone should be enough to forewarn you that too much stage 2 drawing is a trap. Let's say you're not convinced yet because you're kind of new to this and you're still not sure of the methodology and whatnot, not sure of yourself. Just map out the first few possibilities, no more than 3. Placing the GJ block somewhere is a good start of mapping possibilities. And then after having attempted that, recognize that the danger signs are there, that there's too much stage 2 drawing and that it's going to be a trap. So at this point, either because of the GJ block or because of the M rule that forces us to place another M into the diagram somewhere, either one should have given you enough warning signs to be like, okay, stop drawing for stage 2. Just at this point, get ready to plug and chug answer choices. But before you do that, maybe get a pretty clear and solid understanding of the rules and how they interact. Don't do anything past that. So yeah, again, All the red flags in stage 2 tell you do not really do too much drawing, just gain a sense of how the rules tend to interact and how the entities tend to interact. And so having done that, we then move into stage 3. And again, the first thing to do in this situation is to hunt for quick rule-based eliminations. They don't always give them to you, but they're almost I would say maybe a 50-50 split, 40-60, who knows. There's a pretty good chance they will give you a couple. And here in our case, we lucked out and we got 2 eliminations. Those are wrong because of how we were supposed to treat J. So we eliminate those immediately from the running, so we're left with A, C, and E. And then of those 3 remaining, we just start with A and plug it in according to stage 3 analysis, dictated by the table of power, and we just go from there. If A didn't work out, we lucked out that it did, but let's say A didn't have the right information, just move to C. Do that. If that doesn't work out, move to E, and then that's it. Of course, there is that nightmarish situation where you got something wrong, and you didn't understand something of the game, eliminated all 5. That's something that needs more individualized attention from me, so I won't discuss that here. But as usual, I'll put in my spiel. If you find yourself in that situation after having tried this method and various other methods, if you are running into situations where you've eliminated all 5, there's no greater sign that you have missed something about the game. And avoiding those things is highly individualized, so I don't really have the time and the space to put a big conversation about that here. Just email me. Again, my email is in the channel information on the About Me section, as well as the last slide of this presentation. So on the subject of individualization and everybody's differing experiences, in my experience, the line between stage 2, the one where you want to keep drawing more possible diagrams, and stage 3, when you decide to stop drawing but just get a general handle on how the game works and move on to answer choices. The line between those 2 stages really is quite personal. And again, I haven't made this section because these Logic Games lessons are the very first things that I've uploaded to the channel. I haven't made them yet. I haven't finished them yet. I've written scripts for them. But there's a reason why this kind of thing is so personal. And I think it has to do with how our brains work. And our brains, surprise, surprise, people's brains kind of work differently. We have different strengths, different weaknesses, different ways of tackling problems. And because of that, and particularly because of language, I think, this sort of line between how do you make the call for you, when to stop stage 2 and when to move on to stage 3, is personal. I haven't, generally speaking, students do fall into similar ranges, but I have yet to see one student where I could just say the exact same thing that I've told the previous student, and it's exactly what works out. You do have to find your own line. So the question now remains, well, how do you find that line? I've showed you my line, which is anything that exceeds 3 pictures, I just refuse to do for stage 2. So the moment I hit 3 pictures, I'm like, okay, this is a trap. I'm just going to focus only on the rules, not on actually spinning out possibilities, and then move into stage 3. That's where the line is for me. But I just told you that may and probably most likely is not the line for you. How do you find your line? So for that, I do have a proposition for you. For the past 10 years or so, I have been setting students off on the following drill, and it's had pretty good results, if I do say so myself. Try this. Work on a single game, untimed, using almost purely stage 1 and stage 3 analysis. Just skip stage 2 entirely, grind out a stage 3 analysis for applicable questions. Obviously, like we said, the rule checker question doesn't really work, the rule changer question doesn't work, some of the other in-between question types may not work that well, but everywhere you can, just skip the, hey, let's see what's possible part of stage 2, and just grind out answer choice checking, and do that. When you're finished with working on the game that way, do not grade the game. Do not look at any sort of resource that has an answer key. But instead, go back and do the same game again. I know it's a little bit... It can get a little bit rough, but at least you'll have the benefit of having seen the game, so it won't be like you're doing it fresh. This time, do as much stage 2 analysis as you want. Take note of any questions where your answer changes based on that as well. But do as much stage 2 as you feel like doing before engaging into stage 3. Then grade the game, especially if your answers have changed. Make sure that you're recording and grading according to a pure stage 3 versus a max stage 2. So the first version of the game that you tried and the second version of the game that you tried, grade those separately. And then kind of look back at the following factors. Compare your raw performance between both versions, so the pure stage 3 game, the pure stage 2 game. Compare your raw performance on those 2 iterations of the same game. And really, I wish I had a less vague, wishy-washy term for it, but I think it's the best I can do. How you felt about the purely stage 3 versus versus the combined stage 2 and 3 approach. Students report seeing stuff like this. So on X question, the purely stage 3 part like took forever. It took way too long. It was just not practical for a testing situation. But when I did it again with some stage 2 work, it made a lot more sense, and I could see that doing some stage 2 work got me to stage 3 a little bit faster, and it didn't take nearly as long. Or another thing I hear, pretty often is on Y question, I've kind of felt like I needed more stage 2 work, but it turns out I could have gotten away with less of it. I spun out like 6 possibilities, and ultimately they helped, yeah, but I didn't need to do nearly as much work as I thought. I could nail it down by adding stage 3 work faster instead of insisting on doing all the stage 2 possibilities. It's this sort of stuff that's going to help you find, for you, about when and what situations where you should stop doing stage 2 and start doing stage 3. Again, that point seems to be different. And it's not just about one particular game, it's really about how you look at a game and how you look at a question across this entire exam, across all the possible games out there, and what sort of language tips you off to that sort of stuff. Developing that sort of ineffable, unnameable sense of this is what works for me. That's very important. That is very, very important, because they're not to really knock the corporatized test prep solutions, but there's a reason why the biggest names in the business that used to run classes of 30 people at once, why those pretty universally are known for not really helping people get really high scores. They're good for maybe getting close to 160 or even breaking it, but truth be told, if you're starting like my situation, where my very first diagnostic that I took was, I think, in the 130s. It was terrible, because I just had no idea how to do a game, and first time I'd ever seen it. So it was my diagnostic, so I hard timed it and everything. It was just awful. A corporatized test prep solution probably would not have helped somebody with my starting score get to my ending score, which is a 180. They just can't do that, because they are a bit of a one size fits all solution, and we're not one size. That's just the truth of the matter. We're just not one size when it comes to cognitive tasks like this. So yeah, finding your own individual point is important. And again, I always encourage my students to look at competitors, and I almost without fail, at least in the last 10, 11 years, pretty much ever since I started taking high scoring students only. Since that point, almost without exception, the students who come to me have been preparing extensively on their own meaning before they met me, using some other resource. PowerScore is a very common one. I'm hearing the LSAT trainer a little bit more often now, but the Kaplans, the Princeton reviews, those are all just very common things for me to hear. I happen to know basically nothing about any of those. I do know a little bit about Kaplan only because I taught for them for a couple of years. But I'm sure they've updated their program since, and I haven't kept up with it because I don't have to. I don't work for them, and I don't take their classes, so yeah, I just have no reason to. So part of me encouraging students to look at other resources is because I'm also lazy. That way I don't have to personally do it. They just find something that works and they go with that. But the other thing is that it is personal. I don't have all the answers. I do what I do, and I'm putting these videos up because I think having more different kinds of answers may help you put together your ultimate kit that helps you personally get over the finish line, whatever the finish line is for you. But yeah, I'm not going to presume that I have the solutions for everybody. If I did, then I would be probably a lot richer than I am now. People would figure out if I had all the answers. Like if this worked for everybody and this is all that you needed, I'd be ridiculously rich probably at this point. Or then again, I'm bad at marketing and I'm pretty lazy, so maybe I wouldn't be quite so fabulously rich. But you get the point. I would be some huge sensation, and clearly I'm not, because just look at the numbers, look at my metrics. It's not there. So I've done very well for myself in sort of quiet circles, getting referrals from previous students, that sort of thing. But I really do think that because I keep hearing the same things from students, that the game really hasn't changed. And I think I have something extra to offer, and that's why I have people do other things as well. I encourage you to look at other solutions. Take what works from you there, piece together your own little Frankenstein monster, and make something that works for you, because ultimately you're taking the exam. Not me, not Kaplan, not Princeton Review, not Blueprint, not Manhattan. Who else is there? Oh, especially not PowerScore. PowerScore is like really, really popular, right? All those guys, they're not gonna take it for you. They really can't. So it's you, and what works for you invariably is going to be a little bit individualized. There's not one single program that's going to solve all of your problems. Yeah, it's just not how it works. So I had half a mind to cut out all the sort of data advice section from the last slide, but I'm bad at video and audio editing, so you're stuck with it. But moving on from that data advice bit, going back to the drill a little bit. Do the drill that I listed as many times as you want, but in practice I find that most people can find their personal stage 2, stage 3 dividing line within 1 or 2 complete LG sections, which translates to about 4 to 8 games total with this drill. And spacing that out over 2 weeks roughly seems to be enough for most people, at least the people who work one-on-one with me. So if you're doing the drill but you don't know how to interpret the results, or think you might be missing something, or just doing it wrong, or you just don't get what I said, and you're interested in figuring out what it is exactly that I'm trying to tell you, again, I've said it several times, I'll say it again, feel free to contact me via the information provided on the next slide, or in the sort of About Me contact section of the channel, and we'll see how I can help you. And I just want to note here, I should have probably made a note of this somewhere else in the channel as well. Yes, I do this for money, and I do charge a pretty steep rate for most markets, $100 an hour. That's my universal rate for everybody. I just kind of do the same thing because A, my time is valuable, and B, I like to charge the same rate for everybody, just out of fairness to the students who are paying the full rate. But just because you email me doesn't mean that you're locked into like a half hour or an hour of tutoring, and there I'm going to charge you $50 to $100. That's not how it works. If it's something that I can probably fix for you over just like a targeted email, let's say you don't really have that much of a problem, but you just came across a game where like, man, the stage 3 stuff, stage 2, like none of this seems to work for this question. What the hell am I doing wrong? Or does James have anything actually to say about this? And you're curious, just email me, and if I can solve it in an email, there's I don't charge for that. That's just how it is. So generally speaking, the rule of thumb for me is if I can kind of get your problems reasonably solved within a half hour, there's no charge. A half hour is kind of the threshold after which point I'm like, okay, it's time to make this kind of a formal relationship. We'll set up an email thread. I'll send you my usual spiel about how lessons work and all that, even if we only have 1 or 2 meetings as a result, just to kind of formalize things. So yeah, don't hesitate to reach out to me. I am not. This is not really my day job, so to speak. It's something that I've been doing for a while, but I oddly enough do it because I enjoy it, and I think the enjoyment of it, it's not some like masochistic thing. Logic is just something that I've always liked. And so this test being not almost purely, it really kind of is purely logic. And me having reached what I consider the pinnacle of it in a lot of ways. Pinnacle of the test, not so much of instruction. I understand that there's probably quite a bit of I still have yet to learn as an instructor. But yeah, I like this stuff, so it's not something that's always worked to me. So if it's something quick I can do for you, I'd be more than happy to. And that's why I'm constantly making that offer. Reach out to me. There may be something quick I can do for you that solves your problem, and you don't have to worry about charges or anything like that. And that brings us to the conclusion of this particular presentation. Thanks for making it all the way to the end. Time to pander to the algorithm. Like and subscribe, that helps the channel. Leave a comment, that also especially helps pander to the algorithm. And aside from the algorithmic stuff, if you have anything you want to contact me about, again, the email address provided here, shycity180@gmail.com, for any further questions. And of course, if what you see here is interesting you in perhaps starting tutoring with me, which we can do over the internet, in person is going to be difficult with my schedule, but I can meet anybody in basically any time zone over the internet. That should always be directed to that email as well. And again, if you need practice material, I recommend only using the official LSAT materials. It's not, again, because I discredit any of the other test prep solutions out there. I just don't feel I can recommend any of the other ones because I don't know anything about the other ones. I do hear increasingly these days from students that a lot of what I'm saying has also been echoed by the LSAT trainer. I guess that's what that program is called. Again, I think they have a YouTube channel. I'm pretty sure they sound like the kind of outfit that has a website and so formalized instruction. But again, I haven't seen a single one of their things because I don't have to, and I'm kind of lazy. And I'm also a little bit, I guess, prideful. I'm a little bit arrogant. I don't think I need to learn anything different. And to the extent that my students need anything different, I will leave that up to them based on the gaps that my instruction leaves them. So again, I'm not recommending against any of the other ones. I just simply have no knowledge, so I'm not going to affirmatively recommend anything. The only thing that I am ultimately familiar with is the official material, and that has the benefit of not only being official material, but also being quite extensive. You do have access to absolutely everything, and you don't have any fluff that doesn't work for you. so it's kind of safe in that aspect. So yeah, and reaching the Amazon links or sites that sell this stuff through my links in the pinned comment below also helps the channel, because like I said, I'm not doing this really just for the money, but it would help if this effort, because it was surprisingly difficult for me to just basically put up, even though I'm just adding a soundtrack to a PowerPoint presentation, uploading this video, that has been surprisingly time consuming for me. So to make this effort self-sustaining, the affiliate links definitely help with that. So please, if you are looking to get LSAC materials, the official LSAC materials, I would highly recommend trying to get one through the affiliate link that I provided. Otherwise, thanks for watching, and I will see you in the next one.